Hi,
Hi, sir, again.
hi. How are you?
I'm good, sir. How are you?
I'm also good. So we were what we doing last time?
Sir, we were doing thermal
Yes,
effects.
sister.
That's right, sister.
Okay. Fine. You're doing the thermal physics, right?
We were supposed to start the different types of heat transfers like radiation, convection, and conduction.
Okay, got it. Have you studied these things before?
Yes.
Okay. You've not done anything on this?
On radiation, conduction, convection?
Yeah.
Yeah, I have. I've studied about them.
On like here?
No,
No, we not done that. So what we did last time then?
we did. We did. Yeah, we did thermal expansion.
We did thermal expansion
Like
and
bimetal strip. And then we also did expansion in like gas and all that. Expansion, comparison, constant temperature, V equals constant, like pressure is proportional to temperature.
like different laws, Boyle's law, Charles' law, Galilei's law.
Oh, Gale is like the law, yeah.
Yeah, okay, fine, makes sense. Yes. So can you explain me what is metal expansion? What do we mean by that?
Okay, so basically metal expansion is when the particles in the metal vibrate and due to the heat that they're getting, they like move away from each other. So that causes the metal to expand. And it's not the like it's not like a really big expansion. They like expand like for different metals there's like different expansions. Like for steel it's 0.1 millimeter, for concrete it's 0.1 millimeter like that.
Okay. So, okay, I understood. Like you said, like if you increase the temperature, the molecule will gain the energy. They would start getting away from each other. They would start expanding. That makes sense. But what if is there any use of it? Like where do we use it then?
So like we use it in different things, like in buildings when like you need a steel to like make sure the concrete stays on top.
Mhm.
So we usually use metals to make the building stronger. So concrete expands by 0.1 millimeter due to like heat. And we needed to find a metal that expands the same so that the building doesn't come crumpling down. So we used steel. Another really good example is like the bimetal strip in like in a thermostat like heater or in like an alarm. So what happens is when the temperature rises, that temperature goes to the strip, like there are two metal strips. It goes to the bottom strip, and the bottom strip like expands, it like bends. And when it bends, it sends off like a signal. Like I'm not sure, but yeah, when it bends, the heater gets this thing that oh, there's a lot of temperature, it's really hot, so we should like it should switch off. So it switches itself off. And when like the bimetal strip becomes straight again, like contracts, it turns itself back on, or another person automatic turns it on. That's it. That's an example.
So, for example, let's say if it start bending, like one metal is higher and one is lower thermal expansion, it's just going to bend like this, right?
Yeah.
And that's how it just lose the connection, and there's no current flow to the circuit, and then it is used as a thermostat, like maybe in the fridges, or maybe in a heater. For example, if I have to boil the water, I just turn on the heater. Now the moment the temperature, I mean, it reaches certain temperature, the heater stops. Why it happens? Because that connection, it will be start bending, the thermostat start bending, the connection is lost, there's no circuit, then there's no current flows through it, and the circuit will turn off, right? And then again, when it just cool down again, right? So the moment it just starts cooling down again, that bimetallic strip again becomes straight, and then again the circuit will start and it allow the current to pass through it. Um so just tell me one thing. If the metal is expanding, so what will happen to those to the roads or maybe some metal structures, is they are going to get the cracks, or what can we do to to handle this problem?
We can leave expansion gaps like in railway tracks and everything. So
Mhm.
how much ever it expands when it gets temperature, it can be like they could leave a gap for like both the things. So when it expands, it like touches each other. Because if you don't leave a gap, it's gonna like expand, it's gonna come back, it's gonna like break. And that'd be really bad because like trains that run on these tracks, it like just falls down when there's like a tiny like break also in the track. So in order to avoid this, they like leave an expansion gap, which like is exactly the amount or like the length that that metal expands when it gains heat. So that's one way.
Okay, makes sense. So if we don't do that, then
It's gonna like it's gonna like it's gonna keep expanding and pushing each other, and then it's gonna like break because of
uh,
the
I
pressure.
mean, either there would be the increase in the length would result in the cracks, or it will, uh, bend from its path. So there are lot of problems that can be there. Um, Fine. And what else you said? We studied about the thermal expansion. You said,
Yes, that
yeah.
yeah.
Tell me one thing. For example, if you have a balloon, okay, you filled it with the air, right? And now you just place it in a freezer for some time. What changes do you observe?
If you put a like balloon in a freezer, it shrinks.
And why do you say that?
Because I think the particles there lose like heat energy. No, wait. Yeah, it does, yeah, it loses heat energy definitely because it's getting cooled. So the like kinetic energy, they don't like combust or like they don't collide more, so that so it doesn't expand. It just shrinks, I think. Yeah.
Yeah, I mean, like, because the pressure is proportional to the temperature, we call it as a Charles law. So if the temperature increases, the pressure increases and it expands. But
Yeah.
if you drop the temperature, if you keep it in the freezer, the temperature drops, the molecule become more settled down, so they would start compressing. And then same thing if you place it near something like some near to some heater or something, it would increase its size, right? Okay,
Yeah.
fine,
So I'm just gonna switch on the AC.
sure.
Yes.
Okay, fine. Um, Now let's come to the main topic that we are talking about is the transfer of the heat transfer, right? We know that there are three possible ways in which the heat can be transferred, like the conduction, convection, and the radiation, right? So what do you think about the conduction? What is conduction?
Oh, so basically, conduction is the so for example, we have okay, yeah, we have a hot object here and an object at room temperature here, right? So the hot object, it's in contact. We just keep the hot object right next to the like the room temperature object, like they're touching. Okay.
Mm-hmm. Yeah.
So uh, heat always travels from a hotter object to an object whose temperature is lower than that object, right? So since the room temperature object has a temperature lower than the hotter object, so the heat from this it travels to the neighboring particles, and it like that heat keeps on going until it heats up this object, and this object becomes the one with the higher temperature. So that's basically conduction.
So is it like the flow of heat take place from the high temperature to the low temperature?
Yeah.
And how long will that be process would be done? Will like for example, this object is 100 degree Celsius. The other object is 20 degrees Celsius. So how long, like till the time, till what temperature the process would continue, like the transfer of heat would continue?
Um, I think till the increase in temperature, um, like the increase, like for example, if the hot object is 100 degrees Celsius and it's 20 degrees Celsius, until it becomes 101 or 102, I think.
See, we have to come up somewhere in between. How can you increase the temperature? If this is 100 and this is 20, the it will continue to move. Okay, let just tell me one thing. If you have one container which is completely filled with water, it's like having a container with 10 meters of water in it, height of 10 meters. And another container, same height, but completely nothing inside it, right? So on one side, we have everything in this. On the other side, there is nothing on us. The moment you connect it with a pipe, so what do you think about this? Will the water will be moving from one container to another?
Yeah,
And how long that will that be done?
it's until the water is like over.
Until the water is like over. Can I say that from the container which is completely full, that the container level will start falling down, and the one which is empty, it start going up. So
Oh, until it becomes equal.
yes, at the point when the two of the containers have the same water level, the process would stop. Agreed?
Yes.
That's what
It's
happens,
the same
right?
for temperatures. Until they both reach a
Exactly.
same temperature, then the like it stops.
And
Makes sense.
also one more thing here, if I'm having 100 degrees Celsius and this is 20 degrees Celsius, so 100 will lose the heat energy. So it will drop. And because 20 degrees is gaining that energy, it will increase. At one point of light, let's say it's 50 degrees. At that time, let's say the equilibrium temperature is 50 degree. At that point, the temperatures become equal, so there is no transfer of energy, and the process would come to rest. So it has to be somewhere in between the two. From 100 to 20, it will just lie somewhere in between the two. Is that clear to you?
Yeah.
So we call it like the equilibrium temperature. That would be somewhere in between the two. Is that clear to you?
Yeah.
So the same thing as I explained it to you. Okay, let's take another example for this. For example, if I'm having a frying pan, so if the frying pan, if you look at the frying pan, it's like one part which is I'm actually heating up, and one is the handle, which is not directly influenced by the heat, but I'm just holding it, right? Just
Yeah.
imagine if I start heating the pan, this part will heat up, right? And after some time, I'm still not heating up the handle part, but still, when you touch it, you still feel a little bit it's getting warm up, right? But we are not heating it directly. So from where this heat is coming? From the part which actually is exposed to the heat, the heat is coming to the handle part. And that's the reason we always used to cover the handle with some plastic, fiber or something so that we can easily hold it. So sometimes if the handle is not there, if that cover is not there, we cannot even hold it. Do you understand?
Yeah.
So what is conduction? It's a process of transfer of the heat from one object to another because of the difference of temperature. Is it clear to you? So
Yes.
until and unless the temperature difference is there, the heat is always going to transfer. We will write it down. Don't worry. We'll write it down now. So that's your first process, conduction. Can you explain that again? What is conduction?
It's the flow of heat from a body. Wait, yeah. It's the flow of heat from a body of higher temperature to a body of lower temperature until the temperatures of both bodies are equal.
Hmm. So until both of them get the same temperature, we call it the equilibrium temperature, the process would continue. And the moment you reach there, there is no further transfer of heat energy and everything settles down.
Yeah.
Is it?
So, sir, I could just say that it's the flow of heat from a body of higher temperature to a body of lower temperature until both bodies reach equilibrium temperature.
True, true, exactly. Fine. Okay, so that's your conduction. Let me just write this down. Um, yeah, just write down the heading, the heat transfer. Heat transfer. It is the process. It is the process by which the thermal energy moves from the thermal energy moves from a hotter object or hotter body to a colder body. There are three ways of doing it. The three modes are: the first one we call it the conduction. The second one is your convection. And the third one is going to be your radiation. So these are the three ones: conduction, convection, and the radiation. Got it?
Yes, sir.
Okay. Now let's come to the first one. That's conduction. So in conduction, we said that it is a transfer of heat, the transfer of the heat through a substance, through a substance, without the actual, without the actual movement of the particles, without the actual movement of particles of the substance. It mainly occurs in solids. It mainly occurs in solids. Now let's talk about how does it happen. So, so usually the particles of the place where it's heat up, the particles vibrate faster, and from that part it will transfer the energy to the neighboring particles. Just for example, if this is a rod, I'm heating one part of the rod, so it's only exposed to one part. The heat energy get transferred from one molecule to another. It transfer the energy to this one, this one, this one. So that way, the heat is energy. The heat get transferred to the final molecule. The examples that we talked about is if you place a metal spoon, if you place a metal spoon, it's becoming hot when it is placed maybe under the in a hot tea or something, or maybe
Yeah, it becomes hotter. And
yeah,
like a pan, when you like heat a pan, all
yeah,
it contest
heating outside, yeah,
condenses.
the container, the sides also gets heats up.
Yeah.
The iron rod heated at one end. Right this time?
Yeah.
Is it done? Is
Yes, sir. I'm just writing the example down.
it? Sure.
Done, sir.
Okay. So, yes. Um, so usually you would find the conduction mainly with those which are good conductors. Like maybe, for example, if I'm talking about the metals, you would see the conductors. If you have a plastic, rubber, like all the insulators, you won't find these kind of things there. So
So what about molten metal?
we have another concept there that we will see just after that. So the metals are the good conductors. And you know what? That's the reason if you have to make a utensil, it is always made up of the metals. And if I have to make the handle of it, we always choose
Plastic.
metals like
Or
plastic, wood, or rubber, anything like that, which does not, allow the heat to pass through. So there are a lot of applications of this. The first application that we can see here, it's like the cooking the utensils, which are made up of plastic. Or maybe the wooden handles used for the safety.
done, sir.
Okay, perfect. The next we have is convection. Next process is convection.
Sir, I think I know an
Hmm.
experiment that regards convection.
Yeah, tell me what
Like,
you.
so basically, there's this tube that's like this square kind of tube, and there's like liquid all around it. And we apply a color, like a colored liquid into it. So there's already a liquid, it's like a square kind of tube. Okay, and we put in another colored liquid there, and we like heat it at one end of that square, and the color just goes here, and then it goes here, and then it goes to the heated area, and it keeps on doing that, right? And then you switch the end where you heat it to like another end, and then it goes in the opposite direction. I think that's convection.
So what do you understand by this?
Like wherever there's heat, the liquid moves in that direction.
Or isn't that like you're just only, is it possible to do the convection like the one example you said? Is it possible to do the same experiment if you heat up the entire system at the same time? Will that be convection possible then?
No.
It's not. Okay. And why do you think it's not? You said like on heating up, it will be it will be the case, right? And now you're saying that it's only possible if you heat it at one place.
Yeah, because if you heat it at all ends, like yeah, the heat is going to all the molecules in the liquid. But if you heat it at like one end, you can see that because of heat, the heat transfers to its neighboring particles. But if you heat it at all ends, then the experiment would be quite inaccurate, I feel. Not sure.
So the main thing is I have to create a gradient, right? If I'm heating only one part, I'm just keeping one object to be higher temperature compared to the surrounding. Right. And if there is a gradient, if there is a difference of temperature, as we already know from high temperature to low temperature, there is a flow. If all the particles will heat up to the same temperature, there is no temperature difference, there is no flow of heat. Understood? Okay. Now, my question is, so one of the example you said it's a convection. Where do we find do we find it anywhere else other than this example? In the real life, have you ever like observed
Yeah, when you're heating a liquid.
when you're heating up a liquid, how does it work there?
Like it's like kind of the same as conduction, but it's for liquids. So the
Mhm.
heat moves through the metal.
In the conduction, the molecules were not moving, but when I'm talking about the liquids, or maybe the
The
gas,
molecules are moving.
true. So I cannot say it's similar to conduction. It is something different, right?
Yeah.
So what do you think? How it can be different?
So I think the heat molecules
Mm-hmm.
travel to the molecules that are colder than itself, and it transfers the heat to them, and it like gets heated up like that. Because in solids it can't move. In solids it can't move, so just to the particles right next to it, it would like transfer the heat. But in like liquids, the molecules can slide past each other and move. They're like free. So I think they like and one more thing is that in liquids they like slide past each other, and like it's a random motion. So like when it's traveling, whichever particle, like the particle having heat energy, it travels to some particle. That particle has lower heat energy, it transfers the heat energy there. So vice versa, it keeps on happening until the whole liquid is heated. I think that's what happens. Yeah.
Let's take an example to understand this. I mean, one thing is clear, like in conduction, the molecules were fixed. They were just transferring the heat energy from one particle to the neighboring particle. Agreed?
Yeah.
But here in the convection, the particle itself moves. Okay, for example, let's say I'm sitting in one part of the room. The energy will be for the heat molecules or air molecules which I heat up. They will be moving to the other part of the room. They will actually travel there. So in convection, the molecule, the medium itself will, start moving. But that doesn't happen in conduction because the molecules of the solids are fixed. They cannot move. They just vibrate and transfer the energy. Now let's take a very practical example of it. So, like, uh, have you seen the room heaters?
Yeah.
So how do they perform? Like, where you just place it in one part of the room, right?
Yeah, and then the whole area gets heated.
The whole area get heats up. Now, this experiment of the room heaters is good enough to understand the process of convection. Let's say example, this is my room. It's let's say a big room. I have a heater placed on one part of the room. The moment you keep the heater and you just turn it on, can I say the air patch, which is just closer to the heater, that the temperature would increase?
Yeah.
And the moment the temperature increase, can I say the molecules are going away from each other?
So does this count as diffusion?
No, no, no. Diffusion is completely different.
Okay.
So, can I say that the temperature increases?
Yeah.
And can I say the kinetic energy of the particles would increase?
Yeah.
And can I say the particles, if they're expanding, if they're going away from each other, the molecules are expanding, the particles are expanding, the density would decrease.
Yes.
Earlier, they were very close, density was high. When they are going away, density is low, it gets lower, right? Isn't that this patch of the air, isn't that become lighter because the density is less? Like
Yeah.
hot air balloon. You know how hot air balloons? Have you seen them, hot air balloons?
Yeah.
So what they
The
have,
higher the temperature, the more higher it
so
goes.
this is like a balloon, and they used to heat up the air inside it. So if the temperature increases, the molecules goes away from each other, density decreases, it becomes lighter, and it just rises up in the air. Got it? So the same thing happened here as well. The molecule, the moment it's become lighter, it just goes up in the air. Okay? It just goes up in the air. This patch of the air goes up in the air. The moment it just goes up, can I say the temperature would again, now it's no longer in contact with the heater, right? So the temperature drops. Agreed?
Yeah.
And if the temperature drops, the particles come closer, the density would increase, it's become heavier. it's become heavier. And if anything becomes heavier, like clouds, the moment they get heavier, they start falling down. Correct?
Yeah.
So can you see that there is a cycle that has been formed here? That's called, like, you just kept the heater on one part of the room, but every part of the room, there's a complete circulation of the air take place here, right?
Yeah.
And that's how a convection phenomena works. So here you can see the complete patch of the air. It started going from it carrying the heat from one part. It just goes entirely to the every part of the room. Then it just come back. So you can completely see the circulation of the air. So in the solids, the molecules were not allowed to move, but in convection, the molecules of the air, they have the ability to flow. So they just move for they carry the heat from one part to the another part, and that's how the entire rooms get heats up. Got it? That's
Yeah.
what the convection is. And that's the reason we always keep the room heaters at the base, somewhere near to the surface. Got it? So that's your convection. Another example, if I give you for convection is, um, let's say for example, this is a beach and this some like a coastal areas. This is some river or a sea water on one side. So there is a sea over here, and this is the land. So I'm
Yeah.
talking about during the time of the day. I'm talking about during the daytime. Can I say that just tell me one thing by your own observations? If you touch the land or if you touch the water, which one will seems to you more heat up during the day?
The land. The land.
The land is going to be more heat up, right? So can I say the temperature here
Oh,
is
so like the air above the land
yeah,
during the daytime is hotter and it travels to the sea to like the air, it transfers hot
exactly.
energy to
Correct.
like the air above the sea. And
Yeah,
then during the night, the
the
sea
opposite.
is more humid. And so it transfers that to the land because the land is more cooler.
True, exactly. That's what I'm explaining here. That if the during the time of the day, the land is more heat up. So if it's more heat up, density drops, the air molecules become lighter. So this patch of the air, it's become light and it just rises up in the air. And this reaches over here. The moment it reaches up, the temperature would drops again because it loses the contact with the ground. The density increases, it's becoming heavier and then it just come back to the ground again, I mean to the surface. So during the time of the day, you would see that the air is coming from the sea towards the water. We call it a sea bridge. If we call it a sea bridge. But when you go during the night time, the opposite would be done. So for example, if this is a moon, so let's say this is a moon, this represent the night time. The same phenomena I'm representing here. We have a water molecules over here. During the night time, the lens again, it just cools down
1 minute, sir.
really. Sorry?
So 1 minute.
Sure.
Yes, sir.
So we have during the night time, the temperature of the land decreases, but comparatively with the water during the night time, it's comparatively it's more, okay? Comparatively, the temperature is more. So the density drops, the air patch from here, it rises up in the air, it just goes over here, then it just drops to this point, and then you can see, isn't this time, can you see that water is, the air is moving from the land towards the water? We call it as the land bridge. We call it as the land bridge.
Yeah.
Okay, and you can actually experience that during the time of the day if you go to the sea, to the beach, or if you're going towards during the night time, you can actually experience that. During the day, it seems like the air is coming towards you, and during the night time, you'd see like the opposite is there. Is it clear to you?
Yes, sir.
So convection is like a more way, it's like a way in which the the material like the liquids. Now it's only possible for the medium which can actually travel. So it's only possible for the fluids. The one you said for the air or maybe for the liquids, which has the ability to flow. Okay, it's not possible for the solids. Okay.
Yes.
Another example, if I explain it to you, just imagine, for example, if for any human or for any living creature, the temperature of the human body, let's say the normal temperature of human body is, let's say, 98.6
37 degrees. Yeah.
Fahrenheit. That's like a normal temperature, right? I don't know, somewhere near to that number. Um, Now, even if you find it during the daytime, nighttime, if you do it on this part, that part, everywhere, the body temperature would be same,
Same.
remain constant. Now, how it is possible to have the same temperature? Who is responsible for making the temperature to be same? So here again, the phenomena of convection plays a very important role. So we have blood flows through our arteries, nerves, right? Um, so the blood carries the heat along with it. Okay, blood is like a fluid, it's like a liquid that carries the heat energy. So that heat energy will be traveling every part in the body. That way, the temperature of the human body remains same every time. That's why we call it like the hot-blooded animals, right? Correct.
Yeah.
So that's a convection that makes it possible. So convection is the transfer of the heat energy from one place to another, and that is being done with the help of a medium like something that can flow. It can be air, it can be a liquid, right?
Yeah.
Okay, perfect. Let me just write this down now. Just write this down.
That's it.
Okay, so I just have written the same thing. The transfer of the actual moment of the particles, the hot fluid become lighter, it rises, cool become denser, sinks down. This creates a convection current. That's what we explained, right?
Yeah.
Okay. Example, have you seen like a boiling water, like when you used to boil the water, have you seen that the lower part water molecules, when they heat up, they comes to the top part and that circulation of water take place. And that's how the entire water in that container gets heats up.
Yeah.
Right? You've seen those bubbles like coming out. It's just what? It's just the molecules that they are getting a convection there. And the one example that you said, like you just give you place a ink on one part of the fluid, you just start heating to one part, you can see the convection current. That's the same thing. Okay. But you know what? These conduction, convection, these are processes, they would transfer the heat, but the problem is it's not that fast, right? It will take time because it's like a physical energy transferred, right? Even the convection can be even small, difficult. So conduction, convection, heat is transferred. The problem is the rate of flow would be little lesser. So example can be the boiling water. It can be the example we already explained, the sea bridge, and make sure to draw the diagram of sea bridge and the land bridge, which I made just before that. Uh, or maybe the room heater. Just make this diagram also, okay? The room heater warming air. And if the exam, the question comes up about the convection, just make sure to write down, draw the diagrams. Okay, fine. Write this down.
Done, sir.
Yes, is it done? Perfect.
So, sir, now are we going to do radiation?
Yeah, definitely. We'll do the radiation now. That's the only one left. Okay, write down the heading, radiation. Now, what do you think? What is radiations? Where do you find them?
Mainly from the sun.
Mainly from the sun. And how do you explain that?
So, like, basically from the sun. So, I'm really not sure. So, from the sun, the rays, the sunlight and rays, that's radiation. It's falling and it's falling on Earth and it's heating Earth up. That's basically radiation. And it doesn't always need to be the Earth. I mean the sun. You could like, for example, I think there's this way of making plants grow indoors without using actual sunlight. So you could just like take any light bulb and position it over plants in a completely dark room and give it the same things that it gets outside. That's also radiation. It's like that bulb of light is radiating the plant, I think. Yeah.
So, like, tell me one thing, how it is different? Like, the same work was done by conduction and convection also. What different in radiation? What makes
Also, basically, radiation, you don't need physical contact.
you do?
Contact.
Okay, that doesn't require in convection also. You place the heater in one part of the room. The room heater is not contact with every part in the room. How it's different then? The main difference you will find is the medium. Okay. Between the sun and the earth, there is no medium. It's complete vacuum. Agreed?
Yes.
But still the heat is getting transferred in terms of electromagnetic radiations, right? So it's not about it's not about the heat transfer. The main thing is without the medium. It can transfer with and without the medium. Got it?
Yeah.
Just imagine if between the sun and earth there's no rod, like there's no conduction possible. There's no rod installed between the two. So conduction is out of the frame. There is no air molecules or medium between the sun and the earth. So convection also not possible. We need air molecules, water, some liquid, fluids should be there. Convection also goes out of the picture. The only one which is left is the radiations. So between the sun and the earth, there is no medium. Still, the heat is getting transferred from one part to another, and that is done in the form of electromagnetic waves, or we call it like the radiations. Got it? So that's the thing which makes it different from the others. Fair enough?
Yeah.
So we can write this as it is the transfer of the heat through the electromagnetic. It is a transfer of the heat through electromagnetic waves without needing a material medium. Without needing a material medium. It can occur in it can occur so it's not like it's only possible in vacuum. It can be with or without without the medium. So it can occur in vacuum. It can occur in the air. It can occur in the space. Everywhere it can be possible. Now, how does the heat travel? The heat used to travel in the form of the infrared waves or the IR waves, in the form of infrared. That's a part of electromagnetic wave spectrum. So infrared waves.
What are infrared waves?
That's like electromagnetic wave only. There's like sub-classifications. That's one of them. Like, you know what? Radiations, infrared, or maybe like visual light. So these are like different wavelengths, different frequencies. We just name it differently. So that's like infrared.
Sir, I have a question.
Yes, go
Like,
ahead.
is like radioactivity kind of similar to radiation or?
No, 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 that's completely different. Radioactivity is like a breaking down of the nucleus. You're not breaking down anything, you're just transferring the energy. Okay.
So radioactivity, there's just like it's just like the breaking down or forming new
Exactly.
nuclei.
Like when anything is becoming more unstable, when it's becoming unstable, the nucleus tries to break down to become more stable. Just imagine, for example, if in your own room, let's say you're the only person live there, and let's say you're forced that okay, you have to live with let's say 2 or 3 people. They will also stay in the same room. You'd say okay, it's fine. 2, 3 people, it's fine. Maybe someone say okay, 10 people will live in that small room, then that time you would say okay, I cannot live there. You would that time you would try to split. A split means you would say okay, let's transfer some of the people from this room to some other room, right, to become more stable. So that's the radioactive.
Yeah.
The nucleus become heavier with lots of protons and neutrons. It's very difficult for it to sustain the stability. So it will break down. It will split in 2 parts, 3 parts to become more stable. That's a radioactivity. Okay,
Yes.
and this is radiation. There's no relation though. So example can be heat from the sun, which is reaching the earth in the form of infrared radiations. And also, you know what? If there is a campfire and you're just sitting close to it, you're not directly touching the heat, but you're just sitting in the close by, you start feeling warmth of the heat because the heat is coming in the form of radiations. So heat, feeling warmth from the air. Now, what's best about this radiation? The earlier two methods, like the conduction and convection, they were very slow. It's not like just you just put the spoon in a hot object and the at the very same instant the spoon getting heat up. It doesn't happen this way. You have to keep it for maybe 5 minutes, 10 minutes, and then when you touch it, you feel okay, it's getting heat up. But radiation is very quick. It travels, it makes the heat to flow at the speed of light. Okay, just
It
imagine from the sun to the earth, it hardly takes 8 minutes to reach the radiations to reach the earth. Otherwise, if it was a conduction, it takes a very long time. Okay. And even, for example, if I turn on the air conditioner in my room, at least it will take 10 to 15 minutes to cool down. Or even if I place the room heater, even my room is very small, maybe let's say 150 square feet, but still it takes 10 to 15 minutes. Right. So conduction convections are kind of a slower process, but this process is the fastest one. So the important point about this method is it is the fastest mode of heat transfer. is the
Yeah.
fastest mode of heat transfer. And the best part is there is no medium required. There is no medium required. Now, where do we use these applications? Let's look at the applications of the radiations. Applications can be, it can be used in the solar cookers. It can be used in a thermo flask or the thermos flask. It can be used in the back and bottom of the cooking utensils. Let's leave that part this way. So there are like a lot of examples that we can see for radiations. Is it clear to you?
Yes. So how do you rank all three modes of heat transfer according to speed? Like
So
radiation is
radiation, no doubt, is winning all the time. The second one is going to be your convection, and the third one is your conduction. Now, see again, even if you rank it, there are like a lot of factors depending. So I'm a bit confused with the conduction and convection because I have to check for what kind of medium I'm talking about. It's like more dense, less dense, right? So one thing is very clear: the radiation is at the top. There can be somewhere here and there between the conduction and convection, but mostly convection would be stronger. Okay. Is it clear to you?
yes, sir.
Okay, perfect. Fine. Now let's go ahead and tell me the difference between all the three of them.
Okay, sir. So conduction, it's the transfer of heat from a hotter object to a colder object.
My first question, why we are talking about the transfer of heat? Why we need to transfer it? Do I need to do it by myself or is it done by automatically?
No. It is the okay, so sir, you're asking me the def why we're doing heat transfer.
Yeah, I have no idea about the conduction convert. Let's leave those everything. I mean, I'm just saying the transfer is there. Heat is getting transferred, but why? Why the heat wants to transfer?
Because a hotter object always needs to transfer like heat energy. For heat energy travels from a hotter object to a colder object.
Now
That's
you're
why.
saying that it happens, but why? My question is why? Because the hot object needs the higher energy. So it's a law of nature, higher potential to lower potential. Like just imagine if I have water, or the water coming out of the water maybe from a certain height. I don't need to force it. If I just drop the water from certain height, it has to go down because high, like a waterfall, the water always goes down, right? Because it's a high energy. That's a law of nature. Higher potential to lower potential. Okay, go ahead with the conduction.
Yeah. So conduction is the transfer of heat energy from a object with high temperature to an object with lower temperature, um, until equilibrium temperature is reached. And
Mhm,
examples are metal spoon, metal spoon in like hot tea, or an iron rod heated at one end. Convection and like conduction only occurs in solids. And convection only occurs in fluids, such as liquids and gases. So convection is basically transfer of heat by actual movement of fluid particles. It mainly occurs, so it mainly occurs, yeah, that's it. It mainly occurs in fluids. I said that, yeah. And examples are like boiling water and sea breeze and land breeze and heat or warming air. And
mhm,
radiation is a transfer of heat through electromagnetic waves without heating a material medium, without needing a material medium.
mhm.
It can occur in vacuum airspace, which is basically the main highlight, and it's very fast. Um, and examples are heat from the sun reaching the earth, feeling warm from the air, etc. Its applications are solar cookers and thermal flasks.
Okay. And what is sea breeze and the land bridge?
So basically, sea breeze is when during the daytime the land has a lot of hot air. So the hot air from the land it rises high and then it reaches the air above the sea. So the air above the sea now becomes hotter during the day, right? And during the night, the air above the sea is more, and the land has colder air above it. So the air above the sea rises until it reaches the land, and the land becomes hot. So that's why during coastal areas, the land is colder, kind of colder during the a day, and during the night, it's hotter on the land.
Makes sense. Do you take part in the debates in the school?
No, I
You, sh-
used
you
I
should.
should.
Yes.
Thank you, sir.
Fine. So these are the different modes of heat transfer, conduction, convection, and radiation. Fine.
Yeah.
And discuss the rest of it in next class. Fine.
Yes, sir.
Okay, bye.
Bye, sir. Thank you, sir.